Hi, welcome back to A World of Code. Today's going to be our first real lesson, because we're actually going to start writing some queries. In this lesson, we're looking at how to write a simple select query. Select queries are how we get the information we want out of the database. This is the most basic form of a select query. The components themselves can be complicated, and there are all sorts of optional components that can be included to make more complex queries. But these are the core components that all select queries must have. The select keyword, the data we actually want, the from keyword, where the data is coming from, and a query terminator, usually a semicolon. This semicolon lets the database know that this is the end of our query. This serves a few purposes. For one thing, long queries are usually split into multiple lines to make them easier to read. So the end of a line isn't necessarily the end of a query. Second, in longer, more complex queries, the line between where one query ends and another begins can be hard to determine, at least to a human reading it. The data source is where the data we want is coming from. This isn't exactly the same as where it's located. We can have very complex data sources. For instance, the data source for this query could be another query, but the simplest data source here is, of course, a table. Over here, we have an Excel spreadsheet representing our example database. In it, we have an employees table filled with employee type information. I've already set this database up in SQL Fiddle as well, so we can query the data that's in here. So to start, we'll run a query against our data source, the employees table. The database stores data in rows. Each row in the employees table represents an employee. When we query a table, it returns the data we want from each row of the table from which we want it. Again, there are lots of complex and interesting things we can ask for here. But the most obvious thing we would want from the rows of a table are its columns. So for the desired data part of the query, we can write in the names of the columns we want returned. For this example, let's say we have a memo that needs to go out to every employee. We'll want their names, so we know whose information we're looking at, and also their email addresses. So for the desired data, I'll enter the columns employee name and email address separated by a comma. Oracle isn't case sensitive, so it doesn't matter here whether these letters are uppercase or lowercase. Same for the keywords here. But it's sort of standard practice to use uppercase letters for keywords and lowercase letters for table names and column names and so on. I've called this column employee name rather than simply name because name is already an Oracle database keyword. It likely wouldn't cause an issue. Oracle database is pretty good about determining whether something is a keyword or a column based on the context, but it's best to just avoid any ambiguity. These columns are written this way with an underscore, as it's common in column names with multiple words for the words to be separated by an underscore. It is possible to create table and column names with spaces in them, but it's considered bad practice. So let's run this query against our database and see what we get. And there we are, a list of employee names with email addresses. When writing a select query, commas are always used to separate the columns we want returned. For instance, if we also wanted the employee's salary, then after email address, we'd add another comma and then the column name salary. And running that, we see that that gives us our list of employees with email addresses and salary. So what if we want all the information? We want to look at the whole database, like we are here with the Excel version. Our query can simply be select, then a comma-separated list of all of the columns from employees, semicolon. And we can see that this works. But it's a little cumbersome for something which is so common to want to do. every time you want to see the table at a glance, you'd have to type out every single column name. What if you're not really sure what all of the column names even are? You can look those up, but it's a little inconvenient. SQL databases have a shortcut for this. I can replace this entire list of columns with an asterisk. The asterisk here is a special symbol which means all the columns. This is normally read as select all from employees, or sometimes select star from employees. This is among the most basic and simple examples of a query to just get everything from a table. And because it's so common, this notation gets used a lot. Now, depending on the situation, especially in a production system, this might not be the best choice, and it's often better to be completely explicit about every column you want. For example, if your query is returning data to be sent over some service, and at some point someone changes the table and adds a few columns, your query might suddenly be supplying information that was never meant to be sent. But for us, to just check some data, and especially while constructing these queries, it's very helpful. You can always go back and replace an asterisk once you're sure your query is returning what you want it to, and you've narrowed down the columns that you care to have returned. Now that we've looked at choosing which columns we want the database to show us, it's time we look at choosing which rows we want to see. In our previous example, we wanted a list of the email addresses of all of the employees, but much of the time we won't want to see every row of a table, just the rows which meet certain conditions that we care about. For example, let's assume this memo we want to send out is only for full-time employees. Our company might have thousands of employees. We don't want the database to give us every row and then have to go through every row by hand picking out the full-time employees. We only want the rows where employee type is FT for full-time. For that, we need to expand our basic form of a select query to include this optional section at the end. We only want to select the desired data, and here I'm going to change desired data to desired columns, since no matter what, the data returned by the database will always be represented as columns in a table, from our data source where some condition is met. This section of a query is called a where clause. Again, looking at the most straightforward example, we want the rows where one of the columns, in this case employee type, is equal to some value, in this case FT. We write that as select all from employees where employee type equals FT, semicolon. FT must be surrounded by single quotes, because that's how we denote character type data, as in, these are text characters. There are other data types as well, such as numbers and dates, and we'll talk about those as they come up. Let's try running that and see what we get. And just as we'd expect, we get a list of all of our full-time employees. I think it's going to be easier to just jump right into more examples to get a feel for how this section of the query kind of works. Often an explanation just falls flat if we don't have the context to make sense of things, so I think it's going to make things easier if we just jump right in, and I'll give a more formal explanation of everything we can do here after that. Okay, so let's say we need a list of all of the employees who make more than $150,000 a year. We start with our select all from employees, then we want the employees where salary is greater than $150,000. This is very similar to our last query. We're checking one of the columns of the table against a fixed value. But in this case, we have a greater than symbol instead of equals, and our number isn't in single quotes like FT was up here. Number type data doesn't need quotes. We can put the number in quotes, and it will still work. Oracle Database will try to implicitly convert between number and character types where appropriate, but we're going to leave them off. Running this, we see that we get our list, and everyone here makes more than $150,000. So that seems to work. Let's take a look again at the full table. So right here, what happened to Steve? He makes exactly $150,000 a year, but he wasn't included in our list. We probably want him there. If we're doing something where we need all employees making more than $150,000, we probably want to include someone who's making exactly that amount. So let's see what we can do. Well, one thing we could try is to change the amount here. We could query for everyone making greater than $149,999.99 a year. You can't make an amount between this and $150,000. But still, it's a bit awkward. For this situation, we have another symbol. This is read as greater than or equal to, just like this symbol you might remember from math class. If we run this now, we see that now Steve shows up, so we won't feel so left out now. But what if we wanted to leave Steve out? What if we really wanted to leave Steve out? Like we just have it in for Steve. Let's query the database for everyone except for Steve. How do we do that? So as always, let's start with our select all from employees. So how do we exclude Steve? Well, how do we identify him? We know his name, so let's start where employee name, and then what? Well, we want employees whose names aren't Steve. So for this, we're going to use this symbol, which means not equal to, just like this symbol from math class. And then we want the names which are not equal to Steve, which again, because it's text, we surround with single quotes. And then our semicolon. If we run that, we see that's our whole table minus Steve. That's great. So we're able to filter our table sum now. One thing you may have noticed with our earlier query for those making greater than $150,000 is we have this other employee, Janet, who also got excluded from the list because she also makes exactly $150,000 a year. Our next query for those making greater than or equal to $150,000 fixed that. And she was included, which is great. But what if we still wanted to exclude Steve? How can we get this list we wanted earlier of employees making greater than or equal to $150,000 and still exclude Steve, as we have it in for him after all? For that, we can use the AND keyword in our where clause. We start out select all from employees, where we need the employees to have a salary greater than or equal to $150,000, so we keep that part of the query the same. And we want employee name not equal to Steve. This symbol, composed of a less than and greater than character, or angle brackets, or however you want to call them, is an alternate version of the not equal to operator used by most SQL databases. It means the exact same thing as this exclamation mark equals symbol from earlier. People coming from other programming languages will likely be more familiar with the earlier version, but this version is actually going to be the preferred one. It complies with SQL standards, and in my career, this is the version I've seen most often. Let's run this and see what we get. Here's our list. It looks much like the list from earlier, but we can see that Janet is on here and Steve is not, just like we wanted. This here, the AND keyword, lets us add additional conditions to our query. After the where keyword, we can have as many conditions as we like. We just have to separate them with the word AND. So let's add another condition. Right now, we're selecting employees earning at or more than $150,000 who aren't Steve. But let's say we want this list, but we only care about the full-time employees. I don't know what part-time employee makes over $150,000 a year, but it looks like we've got a couple, so let's filter them out. We start with the same query as last time. We want to select all from employees where salary is greater than or equal to 150,000, and employee name is not equal to Steve, and employee type is equal to FT. Our query is starting to get a little bit long at this point, so just to make it easier to read, I'm going to split it across multiple lines. Remember that the semicolon is what determines the end of our query, so doing this won't affect anything when we go to run our query. It just lets us see everything without it running off the end of the page. Let's run that. And there we go. The part-time employees are gone. So there's quite a lot we can do with our where clause now, and we can get pretty specific with our queries. So now what if our company is restructuring and we're going to be losing all of our part-time employees, so we want to get a list of them. But Steve's been rubbing us the wrong way lately, and so even though he's full-time, he's got to go too. Let's start by selecting part-time employees. So select all from employees, where employee type equals PT. Let's run that right now and see what we get so far. Here we have a list of part-time employees, just as we expect. So now we need to include Steve. How do we do that? Well, let's try what we did last time. After this condition, let's add the word and employee name equals Steve. Let's see what we get when we run that. And we get nothing. So what's the problem here? Let's take a look at our query. We're asking for employees who are part-time and are Steve. It's important to avoid any confusion here. This query is not asking for employees who are part-time and then also asking for employees who are Steve. A select query selects for rows. The where clause imposes conditions on what must be true for each row. That means every condition here must be true for every employee returned by this query. If we look at Steve, we see that it's true that his name is Steve, but it is not true that he's part-time. Looking at one of our part-time employees, Sally here, we see that while it's true that she's part-time, it's not true that her name is Steve. There is no employee who is both named Steve and who is also part-time. So this query returns nobody. So how do we actually get what we want here? Let's look at our table and try to determine what it actually is we're asking. We want Steve, and we want Sally and Frank here and any other part-time employee. So what is true of Sally? Well, she's part-time, but she's not named Steve. Same with Frank. Part-time, not named Steve. And Steve, well, he's named Steve, but he's not part-time. So for each of the employees we want in our list, either one of these conditions is true, or the other one is. It's true that Steve is either named Steve, or he is part-time. It's also true that Sally is either named Steve, or she is part-time. It sounds a bit strange when you say it that way, but it is true. What's important is that each employee meets at least one of these conditions. One or the other is true for them. Or both, actually, but we'll look at that in a bit. So for this, we can use the OR keyword. OR is similar to AND in that we can have as many conditions as we want in our where clause separated by the OR keyword. What's different is that they don't all have to be true for each row. Only one of them does. If we run this, we get the list we're looking for. Let's try one more. Suppose we want a list of all of the employees who make either 150,000 or more, or 45,000 or less, or they work part-time. We know how to do this first part, so let's type out select all from employees where salary is greater than or equal to 150,000. Now the second part. This is another condition on salary, and you can probably guess what this symbol is going to look like. It needs to be less than or equal to 45,000. To add another condition, we just use another OR keyword. And now we check whether employee type is equal to PT. And that's it. We run that, and we get our list. All the people earning 150,000 or more, all those earning 45,000 or less, and all the people who are part-time. Right now is a good time to point out that some of these people, like Nate here, meet two of these conditions. He's earning less than 45,000 a year, and also is part-time. That's okay. When you have one condition or another, it's still true if both are true. We don't normally use language this way. For instance, if a waiter asks whether we would like soup or salad, we probably wouldn't say, yes, both. But that doesn't make it an untrue statement. It's just that it's usually the case in everyday life when we say one thing or another, we're talking about mutually exclusive things. Are you happy or are you upset? We could debate about whether one could be both, but generally you'd expect one or the other. But we can ask or questions about anything. Are you blonde or do you have green eyes? There's no reason you couldn't have both. The two things aren't necessarily affected by one another. When answering the question, you probably wouldn't just say yes and leave it at that, but it wouldn't be false to do so. And so, that's sort of how our query works. Is Nate part-time or making less than 45,000 a year? Yes. In general, if thing A and thing B are true, then it's also true that thing A or thing B is true. And in this case, it's also true that he makes at or less than 45,000 a year, or is part-time, or he's making at or more than 150,000 a year. Since only one condition needs to be true with or conditions. Now here I've used another new symbol, the less than or equal to symbol. There are a number of symbols we can use here to compare columns. I'm going to just put a table up on the screen. I've simply referred to these as symbols so far, but we usually call these operators. Just something to remember. We call them that because they perform operations. This right here, 1 equals 1, we call this a comparison operation, an equality comparison operation. We are comparing for equality. And this is the equals operator. This isn't going to affect anything. This is just so that when I call these operators, or if you do your own reading and you see the word operator, you'll know what that means. Going through each of these, you've already seen equals and not equals. We saw greater than at the beginning of the lesson. We haven't seen less than, but I doubt it comes as a surprise at this point. And we have greater than or equal to and less than or equal to. We saw some of these used with text, like equals and not equals for checking the employee name. And some of these we used with numbers, like here with salary. But these can all actually be used with text or numbers or even dates. We won't look at dates today, but they're a type as well, and we can use these same comparisons. Now it's pretty obvious what it means to check for equality, or for a number to be less than another. But what about text? What's less than the word Steve? Let's just try it. Select all from employees, where employee name is less than Steve. And there we go. What do we notice? Tim is gone. Victor's gone as well. What's left is anyone with a name that comes before Steve in alphabetical order. So that's what it means for text to be less than other text. It compares alphabetical order. You may also sometimes see this referred to as lexicographical order. It means the same thing, it's just a fancy way of saying we also include text with numbers in it. Lexicographical order is why if you name files file 1, file 2, and so on up to file 10, you'll see them get sorted with file 10 coming right after file 1. Since when we look at these as strictly text, 1 comes before 2. And this is looked at as 1 and then 0, not as 10. This isn't really important right now, this is just an aside. Also note that this sorting behavior depends on your operating system. The newest version of Windows 10 will sort this with file 10 appearing after file 9 like you might intuitively expect. Now, this isn't a complete list, but I think this is good enough for today. I feel like we've covered quite a bit, and I don't want to put too much material into one lesson. So I'm going to split this one into 2 and end it here. And we'll continue with simple select queries in the next lesson. But before that, if you're feeling particularly studious, take a look at the challenge exercises included with today's lesson. I've put a link in the description to the exercises on my GitHub page, and a link to the video where I go over the solutions. The first part of that video explains how to get set up with SQL Fiddle to run your queries for those exercises, so please check that out. If you want to be notified when new videos come out, please subscribe and click the notification bell. And don't forget to like this video if you did, or dislike it if you didn't. And leave a comment down below either way. It really helps these videos get more exposure. As always, thanks for watching, and I'll see you next time on A World of Code.